Hi team, Miss Prasad here. So we're gonna do our read aloud for our reading guide. So let's get started. I am going to share my screen with you as usual, and then we will just get right on going. Okay, so we are learning about Ohm's law, and basically that is how resistance relates to voltage and current. And we should be pretty familiar with these vocabulary words at this point. And if not, we should go back to our reading guide from last week. Okay, so as always, we want to make sure that we have read our headings and our subheadings. So let's just take a look and do that now. We have Ohm's law relates resistance to voltage and current. And then we're looking here and we have another subheading, which is a sample problem. And we have a box here that talks about dimensional analysis and Ohm's law. Okay, so if you are doing your reading guide right now, you want to be thinking about like, where should I really be paying attention to where my answers are going to come from? Okay, I will read through all of it and then I will go back and make some relevant points that I feel like will be helpful. So yeah, let's get started. So this is Ohm's law relates resistance to voltage and current, paragraph 1. Scientists study black boxes all the time. A black box is an object or phenomenon that you cannot see directly. Scientists will often define something to be a black box and describe it in terms of how it interacts with the world around it. In this section, you investigated a black box electrically to discover the resistor that was inside. Paragraph 2. Highlighting. There we go. You first measured the voltage and current of 3 unknown resistors. The measurements of the voltage and current showed that increasing the voltage increased the current in the circuit. This was true for all 3 resistors. Paragraph 3. The ratio of the voltage to current was constant for any single resistor. For example, data of the voltage and current for the 3 ohm may have looked like the first 2 columns of the chart. The third column is the ratio of voltage to current. So it is talking about this data table here. Okay. So it said that the voltage to current was constant. And here in the third is the ratio of voltage to current. Paragraph 4. The ratio of the voltage to current is equal to the electrical resistance. This relationship is referred to as Ohm's law. Many resistors obey Ohm's law, which states that as voltage increases at a fixed rate, the current increases at the same rate. This is expressed mathematically as R equals V over I. Okay, resistance equals voltage divided by current. So R is resistance in ohms, V is the voltage in volts, and I is the current in amperes. The unit of resistance is the ohm. A 1 ohm resistor connected to a 1 volt battery will draw 1 ampere of current. The symbol for ohm is the Greek letter omega. This equation can be rearranged to calculate the value of any of the terms. V equals Ri, I equals V divided by R. The helpful algebra circle can be used to solve for any of these three variables by covering up the variable you are solving for and viewing the equation. If you want to solve for voltage, cover the V and you will see that you must multiply I by R since they are side by side. If you want to solve for current, cover the I and you will see that you must divide V by R. If you want to solve for resistance, cover the R and you will see that you must divide V by I. Some resistors obey Ohm's law over a wide range of voltages. For these resistors, the value of R always remains the same. Here is our sample problem. The problem reads, a 2 ohm resistor is placed in a circuit. Record the currents corresponding to the voltage measurements of 10 volts and 30 volts. Here's the strategy they are telling you to use. You are asked to calculate current for an unknown resistor. You can use Ohm's law, which shows the relationship among voltage, resistance, and current. You are given in the problem that resistance equals 2 ohms, that voltage equals 10 volts and 30 volts, and they are saying that your solution here is that you will use the formula I, because I stands for current, equals voltage divided by resistance. So I therefore equals, remember we change our variables to 10 volts divided by 2 ohms. So the first resistor is receiving 5 amperes of current. Now, as we see here, we have 2 different volts, so that is why we have to do this again. So you see that they do, if I could highlight, that'd be great. Okay, not working. So you see here, resistance equals 30 volts divided by 2 ohms of resistance. The amount of resistance remained the same, equals 15 amperes. Okay, so one is receiving a current of 5 amperes and the other is receiving a current of 15 amperes. And here is the dimensional analysis for Ohm's law. And basically, dimensional analysis is just saying, how do I go from volts and volts and ohms to amperes? I'm confused, right? So that is what they show you. In the sample problem, you use the equation I equals V divided by R, or current equals volts divided by resistance. Recall that resistance, R, is measured in ohms. And that is the ratio of voltage to current measured in V and A respectively. Also recall that mathematically, V over V divided by A would equal V times A divided by V. You can see that these V's would cancel out and all you'd be left with is the A. Notice how the units cancel out, leaving the unit for current in amperes. So this is how you are showing that through this math, you also come up with the correct unit. Because it's not just about memorizing that, oh, A is for amperes, it's how does that actually mathematically work out? How am I proving this? Okay, so we will be doing a little bit more with math, not in this video, there'll be another one, but let's just go back up quickly and cover a few things. So we see here that voltage and current are here, and then we have these numbers, right? Voltage and current, and then you have that the resistance equals 3. We know this is the resistance because we know that resistance is equal to voltage divided by current, or the ratio of voltage to current, right? So if we weren't sure if that was correct, what we could do is we could test that. So I'm just gonna take the first one, and we see the volts are equal to 1, the voltage is equal to 1, and the current is equal to 0.33 amperes, right? So let's divide those like our formula says. So we have 1 divided by 0.33 equals 3.0303, repeating, right? If we were to round that to our nearest whole number, we get 3. So we can see that our resistance equals that. It is, in fact, the ratio of voltage to current, right? And when we're talking about Ohm's law, you really just need to think of Ohm's law as R equals V divided by I, right? Where it is the relationship between electrical resistance and voltage to current. So you need to be thinking about how resistance is related to voltage to current, okay? When we are looking at our formula sheet, it will look like this, V equals RI. So remember, you can use your formula circle, you would set it up like this, or you can use algebra, okay? You have either option, okay? So we will have another video where we discuss those things. Oh, and as a reminder, here, voltage and V, remember this V is standing for volts, not voltage. So we measure voltage in volts, capital V. We measure current in amperes, capital A. And voltage is the ratio, basically it measures joules per coulomb of charge. So how much energy each charge receives, right? Current is the measurement of coulombs per second. So how fast are the coulombs moving per second, right? So these are ratios, just like when we're talking about resistance, which is the ratio of voltage to current, or volts to amperes, right? If you're talking about the units, okay? So I hope that this has been helpful. Remember, if you need any help at any time, feel free to comment, feel free to email, and let us know anything we can do to make you more successful during this time, okay? I'm happy that you were here, and that's been a Read Aloud with Ms. Prasad. See you next week.